Welcome back to another deep dive. Today, we're looking at something pretty cool, something really futuristic
It's
sounding.
definitely cutting edge.
We're talking about how satellites are going to revolutionize the Internet of Things,
Yeah.
and we've got this research paper to guide us. It's called Satellite Edge Computing Architecture and Network Slice Scheduling for IoT Support.
Catchy.
It is a catchy title, yeah.
Yeah.
And it's by Taeyoon Kim, Jungho Kwak, and Jawan P. Choi. Now, I know that sounds a little intimidating, all that technical jargon, but that's what we're here for.
To break it down.
Exactly. We're going to unpack it all and really look at the coolest, most mind-blowing aspects of this.
Absolutely. And what's exciting is that this isn't just some abstract theoretical paper.
Right.
This research actually provides like a practical roadmap
Yeah.
to connecting every single thing, even in like the most remote corners of the planet.
That is a very ambitious goal, and I think what really struck me when I was reading this paper was how important satellites will be for 6G. Street.
Yeah.
Because, you know, we have cell towers on Earth, but
Right.
there's only so much they can do. Satellites can blanket the entire world, right?
That's exactly it. That's one of the biggest limitations right now.
Yeah.
Is just that terrestrial coverage.
Yeah.
So satellites offer a solution to that, to truly connect every single thing. Imagine you're, I don't know, trekking through the Amazon rainforest
Yeah.
or sailing across the Pacific Ocean,
Yeah.
and your devices are still seamlessly connected.
Yeah.
That's the power of 6G
Wow.
with satellite support. And not just coverage, but speed too.
Yeah, because it's not just about having the signal. It's about having a fast signal,
Exactly.
even when you're in the middle of nowhere.
Exactly.
And that's where those mega constellations of LEO satellites come in,
Right.
like SpaceX Starlink.
Yeah.
Because they're orbiting closer to Earth,
Right.
which means the data travels faster.
Exactly. And that's where the concept of, latency comes in.
Right.
And the lower latency, the better. And this research introduces this really cool concept called satellite edge computing.
Yeah.
SATIC for short. It's like having these mini data centers
Okay.
on these satellites.
Yeah.
So instead of sending data all the way back down to Earth to be processed,
Oh.
you can process it right there on the satellite.
Wow. So instead of my data going from like the sensor in my garden all the way to a data center and then back to my phone,
Exactly.
it could be processed by a satellite just like zipping overhead.
That's right. It's a much more efficient route.
That's amazing.
It is. And especially because, a lot of these Internet of Things devices,
Right.
like sensors and trackers, they don't actually need that much processing power.
Oh.
So SATIC can handle that without any issues.
And that makes me think about the energy it takes to do all this.
Right.
Sending information to space and back, it's got to use a ton of power, right?
Well, you would think so.
Yeah.
Right. That's a very common assumption.
Huh.
But this research actually calculated the optimal balance between speed and energy use.
Okay.
And it turns out offloading data to satellites can actually be up to 30% more energy efficient
Wow.
than traditional methods.
30%. I'm surprised.
That's a pretty significant difference.
Yeah. But how can one single satellite keep up with like millions, maybe billions of devices
Yeah,
sending information all at once?
that's a great question. And that's where the concept of network slicing comes in.
Okay.
So think of it like dedicated lanes in the sky
Okay.
for different types of internet traffic. So you might have one lane for your smart home devices, another lane for self-driving cars that need real-time updates,
Okay.
and another for, businesses handling large data transfers.
So it's like a super organized highway system in space.
Exactly. A highway system in space keeps everything running smoothly.
Yeah.
And get this, they actually tested out this network slicing
Oh, wow.
with 3 different types of virtual networks.
Okay.
So they had one for like basic IoT tasks, like your smart thermostat adjusting the temperature.
Right.
Another for mission critical tasks
Yeah.
that need extra reliability, like emergency alerts.
Yeah.
And then a third one designed for handling massive amounts of data,
Yeah.
like the backbone of the 6G network itself.
So they had like a variety of different types of data
Exactly.
that they were testing this with.
Exactly. To see how it would perform under different demands.
Yeah, it sounds like a very complex system.
It is. It's incredibly complex.
We've got these satellites acting as mini data centers.
Right.
We've got network slicing to organize all the traffic.
Right.
But where exactly do these satellites need to be to like get the best performance?
Right.
Because we talked about LEO, but what about those VLEO satellites? The ones that orbit even closer. Would those be faster?
Yeah. So that's a common question. Intuitively, you would think closer equals faster,
Yeah.
right? But the researchers actually found that sticking with those LEO satellites is actually the most practical choice for now.
Oh.
It's got a sweet spot. You
Uh,
know, it gets the job done. It's cost effective.
Right, because it costs a lot of money to launch these satellites,
It
right?
does. It's a huge factor,
Yeah.
especially when you're talking about launching and maintaining an entire constellation of satellites.
Right. So it's all about finding that balance between like the best performance and what is actually realistic in
Exact.
terms of cost.
Yeah.
But if you've got all these devices
Right.
sending data up to the satellites, there must be some kind of
Yeah.
system
Yeah.
to like prioritize things, right? It can't just be a free-for-all.
You're absolutely right. And they actually developed a smart scheduling system that takes into account how time-sensitive a task is,
Oh.
how much power it requires,
Oh, wow.
and even the strength of the signal from the device.
So there is like a type of air traffic controller up there in space.
You could say that.
Oh my gosh. That's
Yeah.
amazing.
Making sure that the most urgent requests
Right.
get handled first.
Mm-hmm.
So, your smart refrigerator
Yeah.
might have to wait in line behind a self-driving car.
I love that image. Like my refrigerator
Yeah.
is just like, hold on, I need to tell you that we're out of milk. And the satellite's like, no, sorry. Self-driving car has priority.
Exactly.
That's so funny. But it makes sense.
It makes sense. Certain tasks need to take priority.
Yeah. I mean, we've gone from the very basics of satellites and 6G to like the intricacies of static and network slicing.
We've covered a lot of ground.
And we're just getting started.
We are. There's so much more to talk about, especially about the potential impact
Yeah.
of SATEC on your everyday life.
Well, I'm very excited to get to that. But for now, I think we need to let all this information sink in.
It's a lot to process.
We will be right back to continue our deep dive into the world of SATEC.
And what it means for the future of our connected world.
Stay tuned.
Welcome back. Before the break, we were talking about SATEC's potential,
Yeah.
to really change how we connect,
Right.
especially in those hard-to-reach places.
Yeah.
But I'm curious, when you first heard about this, what were your initial thoughts? Like, did this feel like something straight out of science fiction?
A little bit, yeah. It's exciting. The idea that you could have internet access
Right.
anywhere on the planet
Yeah.
is incredible, but it's also, I don't know, a little bit mind-boggling.
Yeah.
I wonder, like, what are the practical steps to even get there?
Yeah, and you're right. It's not like this is going to replace all our ground-based networks overnight.
Right.
Right. It's more about creating like this truly global system where satellites kind of fill in the gaps,
Okay.
and work alongside existing infrastructure.
Right.
So yeah, it's really about creating this world where, connectivity is not limited by geography or infrastructure.
So it's like we're building this network that's a safety net, so that no matter where you are, you're always going to be connected.
Right. I love that. That is such a powerful vision. I can see how that would be so transformative
Yeah.
for so many people, for so many industries. But how do we get from these like theoretical models to the real world? What are
Yeah.
the next steps?
Yeah, well, the researchers actually highlight some areas for future development.
Okay.
And the first one is refining those scheduling algorithms.
Okay.
Remember we talked about those?
Yes.
Like the air traffic controllers for data?
Yes.
They basically make sure that the most urgent requests are prioritized. So they're going to need to become even smarter and more adaptable
Okay.
as the Internet of Things landscape grows.
So it's like air traffic control systems have had to evolve
Right.
as air travel has got more complex.
Exactly. And so will these algorithms. They'll need to be constantly learning and adapting.
Right.
A crucial piece of the puzzle is security.
When you're dealing with data from billions of devices,
Yeah.
security is paramount.
Yeah.
So we need really robust
Yeah.
encryption,
Yeah.
authentication protocols
Yeah.
to safeguard that information.
Right. Because you don't want people hacking into your smart home,
Exactly.
like from space.
Right. Or accessing your personal data. So
Yeah.
there are multiple layers of security to consider, right? Not
Yeah.
just the data itself,
Right.
but the entire network
Yeah.
and even the physical satellites themselves.
Wow.
But let's maybe zoom back in
Okay.
on this specific research.
Okay.
Remember, they actually tested
Yeah.
this SATEC concept with different types of IoT applications.
Yeah.
What did those simulations actually show?
Yeah. They simulated a three different, I guess you could call them like slices
Yes,
of IoT.
right.
And one of those was for massive IoT
Right, MIoT.
or MIoT,
Yeah.
which is basically all those low power devices like
Okay.
sensors.
Like the sensors that are used for environmental monitoring.
Yeah. Or tracking shipments.
Right, exactly. So lots of devices.
Right.
Collecting data, but maybe not needing to send or receive huge amounts all the time.
Right. Okay, so that was one slice. And then they also tested mission critical IoT,
Right, MCIoT.
which is basically all the stuff that like can't fail.
Right, it has to be reliable
Oh, yeah.
and fast.
Yeah, like self-driving cars,
Self-driving cars, yeah.
remote surgery,
Exactly.
controlling critical infrastructure.
That's right, high-stakes stuff.
Yeah. Yeah, so that's a very different type of data than
Yeah.
the MIoT.
Very different.
And then what was the third one?
The third one was 6G backhaul,
Okay.
which is essentially the high-speed pipeline
Okay.
that connects the Earth's internet to that network in the sky.
Right, so it's handling huge amounts of data.
Huge amounts of data,
Yeah.
flowing back and forth. So they really put this SETEC concept through its paces.
Yeah. They wanted to see, like, how does it perform under pressure?
Exactly, with all these different demands.
Yeah.
And what were some of the key takeaways?
Yeah. Was there, like, one best way
Right.
to use SATEC?
So one of the most interesting findings was that the optimal strategy actually varied
Okay.
depending on the type of application.
Okay.
So for example, with those MIoT devices,
Right.
the ones that are more delay tolerant,
Yeah.
it often made more sense to just send the data back to Earth
Oh.
to be processed, especially if the satellite was busy with other requests.
Well, yeah, that makes sense. If it's
And-
not time sensitive,
Right.
why clog up the space data center?
Right, exactly. Exactly.
Right.
But for those mission critical applications where every millisecond counts,
Yeah.
offloading to the satellite was almost always the better approach,
Okay.
even if it meant using a little bit more power.
So in those cases, speed and reliability are just more important
Everything.
than anything else.
Than anything else, yeah. And for that 6G backhaul slice, the ideal strategy kind of depended on a few things,
Okay.
like how much data was flowing, whether there were ground-based resources available to handle it.
Right. So it's like a constant balancing act.
It is.
You know, you're constantly adjusting to what's happening in the network.
Exactly. Exactly.
Yeah.
It's like conducting an orchestra.
Ooh. Like
Right. You've got all these different instruments,
Yeah.
and you got to make sure they're all playing in harmony.
Yeah, and maybe one instrument's louder at some point and then another one's louder at another point. That's a great analogy.
It really is. It highlights the dynamic nature of this technology.
Yeah.
So we've talked about the benefits,
Right.
the challenges,
Yeah.
and what we've learned from simulations.
Yeah.
But now I kind of want to take a step back
Okay.
and look at the bigger picture.
Okay.
How does this research fit into, the world of satellite technology as a whole?
Yeah. I mean, it seems like we're in this like satellite renaissance right now.
We are.
You know, we've got all these advancements in miniaturization,
Mhm.
launch capabilities.
Yeah.
The demand for global connectivity is just exploding.
It is. It is.
So SATEC is definitely like a key player.
It is.
But what else is happening
Right.
that has you excited?
Well, I mean, you mentioned the rise of those massive LEO constellations,
Yeah.
like Starlink.
Right.
They're already providing high-speed internet
Yeah.
to people in remote areas
Yeah.
all over the world.
Yeah.
So that's huge. And then there are new satellite technologies being developed,
Oh, wow.
like optical communication,
Okay.
which promises even faster data speeds and lower latency.
Oh, wow. So it's not just about expanding coverage. It's about
Mhm.
making it even better.
It's about pushing the limits
Yeah.
of what's possible.
Wow.
And there's also growing interest in using satellites for, a whole range of applications.
Yes. Oh, interesting.
Beyond just internet access,
Okay.
things like Earth observation,
Oh, wow.
disaster management,
Okay.
remote sensing,
Yeah.
scientific research.
So we're using satellites for more and more things.
It's like opening up this whole new frontier
Yeah.
for innovation
Yeah.
and exploration.
Yeah.
We're using satellites as platforms for everything.
And SATEC could play a key role in all of this,
It could. It could.
providing the processing power and the data storage
Right.
that
We're-
you need for all these different applications.
Exactly. It's an exciting time to be following this.
Yeah.
The evolution of satellite technology.
Yeah.
And this research really gives us a glimpse into a future where satellites are just even more integrated into our lives.
Yeah.
Connecting us, informing us, empowering us.
Yeah. It's It's really incredible to think about the possibilities.
It is.
And we've covered so much in this deep dive,
We have.
but I feel like we've only just scratched the surface.
We've only just begun. This is a rapidly evolving field,
Yeah,
and we can expect to see even more groundbreaking developments in the years to come.
I can't wait. But before we get ahead of ourselves,
Right.
let's take a moment to kind of digest everything we've learned.
Yeah, let it all sink in.
We'll be right back to wrap up our deep dive
Yeah.
into SAT tech and what it means for you.
A listener.
Stay tuned. Welcome back. We've been on this incredible journey, exploring SAT tech and all its potential. But now I want to bring it back down to earth, literally. What does this mean for the average person?
It's a good question because it's easy to get lost in the technical details.
Yeah.
But ultimately, this is all about how technology can make a real difference in people's lives.
Right, right. So let's paint a picture. Imagine a world where you're not limited by spotty internet or dead zones. You could be working remotely from a cabin in the mountains. You could be, I don't know, streaming your favorite show on a boat in the middle of the ocean. You could be attending a virtual conference from a rural village. SATAC could make that level of connectivity a reality.
Anywhere on the planet.
Yeah.
And think about the implications for things like education,
Yeah.
healthcare, business opportunities for people in those remote or underserved communities.
Right.
It really has the potential to bridge that digital divide
Yeah.
and empower people with access to information and resources.
It's like we're leveling the playing field.
Exactly.
And it's not just about individuals.
No, not at all.
Think about entire industries.
Yeah, I mean, think about how SATIC could revolutionize how we monitor and manage critical infrastructure,
Oh, yeah.
like pipelines, power grids, transportation systems,
Imagine being able to track shipments in real time,
Yeah,
no matter where they are in the world.
or being able to instantly respond
Yeah.
to equipment failures in remote locations.
Yeah. So it makes things more efficient,
Right.
more reliable,
More secure.
more secure. Yeah. And it could even help prevent disasters,
Yeah.
save lives.
Absolutely.
And then there's the impact on scientific research.
Right.
We talked about how SATAC can handle huge amounts of data.
Massive amounts.
That's got to be so valuable for things like Earth observation and climate science.
Exactly. With SATIC, you could analyze data from Earth-observing satellites in real time,
Wow.
gaining crucial insights into things like, I don't know, weather patterns, deforestation, even the movement of wildlife.
So it's like we have this constant stream of information
It's
coming
somewhere-
from space,
yeah.
helping us understand our planet,
Right.
helping us protect our planet.
And make better decisions.
That's incredible. But as this technology evolves, I'm also wondering about what it means for the future of the internet.
What-
Could we see a shift away from traditional internet service providers
Right.
towards more personalized satellite-based connectivity?
It's definitely a possibility. I mean, as SATIC becomes more affordable,
Yeah.
more accessible, I think we're going to see the emergence of new business models,
Right.
new service offerings.
Yeah.
Imagine subscribing to a customized satellite internet plan
Oh, wow.
that meets your specific needs, whether you're a farmer who needs to monitor their crops,
Oh,
or,
I know.
a researcher collecting data in the field, or even a digital nomad working from some exotic location.
So it's it gives people more choice.
More control.
More control
Yeah.
over their connectivity. But with all this potential comes responsibility, right?
Of course.
We have to be mindful of the ethical consideration
Yeah.
and the challenges that come with a technology this powerful.
Absolutely. I mean,
Yeah.
data security, privacy, responsible use, these are all things we need to be thinking about
Yeah.
as SATIC becomes more widespread.
Right. And we also have to think about the environmental impact
Yes, absolutely.
of launching and maintaining all these satellites.
A big consideration.
Yeah, yeah. It's like a reminder that with every technological advancement,
Right.
there are trade-offs.
There are always trade-offs.
But I think the potential benefits here are so significant
Yeah,
that it's a conversation we need to have.
absolutely.
And I think it's up to all of us, researchers, policymakers, businesses, individuals,
Everywhere.
to figure out how to use this technology responsibly.
To shape how this technology is used.
Yeah, to shape how it's developed.
Right.
To make sure that it's creating a better future for everyone.
A more equitable and sustainable future.
Yeah, yeah. And that brings us back to you, the listener.
We've explored the technical side of things,
Yeah.
but now we want to hear from you.
What are your thoughts? How do you see this technology changing your life?
What new possibilities do you see?
What are your concerns? We encourage you to keep exploring this topic, share your insights, and join the conversation.
This is an ongoing discussion.
Yeah, as we navigate this exciting new frontier of satellite technology, thanks for joining us on this deep dive into the world of SATEC.
It's been a pleasure.
We hope you've enjoyed the journey as much as we have.